Hello everyone, I'm Sai Srihita Reddy Tumala and I'm a software engineer intern in the marketing tech team. The marketing tech team handles the message platform, which is responsible for critical communications such as site transaction emails, emails that go between user to user, and even marketing emails which go out of eBay. The communication forms not only include emails, but also eBay messages and even notifications. These communications are usually rendered using templates whose values are filled based on the runtime parameters such as item details, transaction details, or user details. The process of authoring, rendering, and delivering these communications can require them to go through multiple components in the delivery pipeline. Though the system is designed to be fault tolerant, there are still cases where emails are dropped. Errors like external database outages, service call failures, or even rendering errors caused by template updates can cause the delivery pipeline to fail and keep the communications from reaching their intended user. And this is where the message replay project comes in. Message replay project ensures that there is a fallback in case of such communication drops. After troubleshooting the cause for the drops, replay service can be used to redeliver them by putting them back into the delivery pipeline. Message Replay project uses Apache Airflow to create a collection of tasks with relations under the concept called Directed Acyclic Grabs, or DAGs for short. These DAGs schedule the Spark jobs and put the failed dispatches back into the flow. So how does the Spark job scheduled through the Airflow know which communications have failed? There is a component called Message Tracker that writes dispatch logs to the Hadoop file system continuously. These dispatches have parameters which indicate the status of the communication. The Spark job accesses these files and searches for dispatches which indicate failed status. These dispatches are separated and written to a new output path where Airflow takes them to the dispatch service so they can be redelivered. This summer, I had the honor of working on this project to make improvements and introduce a few new features. One such feature was to integrate the SSO with Airflow. Airflow actually provides their own set of login features through a Flask app builder in Python. It uses Airflow database to check the username and password to log the user in. Integrating Airflow with SSO meant I had to leverage the APIs directly, as Python comes under the non-managed stack for eBay and it had no direct support. After successfully integrating the SSO, users can now use their eBay corporate ID to log in instead of having to create the new users manually through command line interface every time the database is reset. But this meant everyone at eBay had access to the DAGs and could trigger the Spark jobs anytime. To further restrict the access, we provide admin access to specific users and provide viewer access to the remaining. In this way, users can be restricted from unintentionally triggering the DAGs. The Airflow schedules the Spark jobs to a Hadoop queue. Initially, the Spark job was connected to a Commerce default queue, which is a shared queue where many of the jobs run. This means at any single point of time, there are multiple jobs running on the queue. During one of the replays, we noticed that the Spark job was taking unusually longer for some of the runs. This job, which usually finishes in nearly 20 minutes, took more than an hour to complete. Upon further investigation, we found that it was due to the Spark job losing its executors. In other words, the Spark job was not getting the optimal amount of resources to finish the job on time. After deliberating on how to improve the performance, the Spark job was moved to the Commerce marketing queue where there weren't as many jobs scheduled. This had significantly improved the performance of the Spark job. The Spark job is now able to process a much larger file in less than 20 minutes. There was also a need for a new DAG which could replay files under specific email templates using their type IDs on a daily basis. Since the replay service was to be triggered manually based on the need, these tasks were separated under a new DAG. The type IDs are passed in the DAG configuration file where each type ID gets a separate Spark job scheduled in parallel. With the new queue's capacity, it was possible to schedule multiple Spark jobs parallelly without having much difficulty in sharing the required resources. As previously mentioned, the message tracker writes logs to the Hadoop file system continuously. It also generates a parameter called bucket ID when it processes the event. The bucket ID is usually used as the time key to find the communication drops during that particular hour of the day. Previously, the bucket ID was synced to the processing time of the event, but occasionally there are chances of the logs being processed at a later time due to some delays. This could potentially cause the replay job to miss the communication drops as they would be put in a later time bucket. So now the bucket ID is instead synced with the time when it was last updated to provide a more accurate time bucket for the communication logs. More changes were also made to the Airflow Replay UI and version to make it easier to schedule the replay job. I also made a few changes to the Docker files of the image to enable Airflow 2.3.2 on tests. I had a lot of fun working on this project and exploring the technical side of the eBay. I'm all the more excited to see what my other projects I'm working on will allow me to learn in my remaining time here at eBay for this summer. Thank you very much for listening to me. If you have any further questions or would like to share your thoughts or suggestions, you're welcome to meet me through my intern showcase or email me anytime. Thank you.